Question 4.2.2 for 3 marks. We're still on the same question. Just to remind you, we found the turning point and we found the coordinates for D. We found the range, and now they're asking us to find the area of OCDE. Now, let me use the highlighter and let's have a look. Of OC, C to D, D to E, and clearly then back to O. Okay, now let's remind ourselves, folk. There's 2 parallel sides here. This axis of symmetry is parallel to the x-axis. So we have 2 parallel sides. Let's write this in the tips. 2 parallel sides, and this means we have a trapezium, or a trapezoid as the Americans would call it. It's called a trapezium here in South Africa. Okay, trapezium has 2 parallel sides, and let's remind ourselves the area of a trapezium on the sketchboard is equal to a half multiplied by the sum of the parallel sides, so the sum of their lengths, multiplied by the base. And in this case, the base is the side that is perpendicular. Okay, here we have. There's a perpendicular angle there, and there's a right angle here. So in plain forward language, it's going to be the sum of DE and OC multiplied by OE, and that product is times by a half. Okay, so let us see what we can find. Can we find the length of OC over here? I'm going to write down here the length of OC. Well, C is the y-intercept of the parabola. So to find that length, I need the y-intercept of either the parabola or of the line, because they both intersect at that point. Now remember, the quickest way to do this, remember our line equation, g of x was a half of x plus 9 over 2, that would be the point 0 and 9 over 2. Obviously, O is the point 0, 0. So OC will be 9 over 2 units long. Okay, that's fine. DE, do we have that? Well, we've got the y-coordinate for E, it's -5. The x-coordinate is 0. We're looking for a vertical length, so we are going to use that 2. Okay, so we can record that DE is indeed that 2 minus 0, which is 2. Now all that's left for us is to find this length of OE. Well, that is going to be easy. We've got the x-coordinate of point E. So that will be the x-coordinate of O minus the x-coordinate of point E. The x-coordinate of O is 0, minus -5 leaves us with a positive 5 for that length. We've got the 3 lengths that we need. So we can go over to phase 2. The area of the trapezium is what we wanted, and that is equal to a half multiplied by the sum of the lengths of the parallel sides, so it's OC plus DE, and all of that is multiplied by the base OE. Now that wasn't so difficult for a good 3 marks. That leaves us with a half. The OC value here, where's OC? OC is 9 over 2, DE is 2, multiplied all of that by 5. So let's do this slowly so we don't make a silly error. 2 is 4 over 2, so this will be 13 divided by 2 inside that bracket. Folks, 5 times 13 is 65. 4 times 4 is, 2 times 2 rather, over there and over there is 4. So this will be 4 units squared, whatever the units are that we're measuring in. So yes, what did you have to remember? You had to remember the formula for the area of a trapezium. Once you had that, Bob was your uncle and you could get this sum done in a jiffy. Okay, be prepared for these type of things to happen in the functions section.